Excuse me, sir.
Yes.
Uh, Sir, while drawing free body diagrams and considering a specific point, do we consider only the forces directly acting on that point, and we
Yes.
ignore the rest of the forces, everything?
Yes, Jen, like I mentioned, if you got a big system and you want to do analysis on any one part, I'm repeating that you cut that part off from the surrounding, and
Okay.
then you apply equation, and then you draw the feedback diagram of that part only. You do not look back to the system. That will confuse you. So
Hmm.
remember, if you want to do analysis on any one part, cut it off from the surrounding, and then do not look at the whole picture. Just look at the cut, that small portion, and then draw a feedback diagram, and then apply equation of equilibrium on it. Okay,
Okay.
you will see that how we do this, because some of the forces may not be available, and it's linked to the whole system. So how can we find those forces? We'll do that in a while. So, excuse me. So feedback diagram are one of the most important things for you to know how to draw and use. Remember that I showed you a picture. Remember this example? It's a tractor. We were looking at the load. I had to find the forces acting on. I had to find the forces on different links here. So if it was very difficult for me to do it on this real picture, so I had to draw a free body diagram of this link. So this is the ideal version. That's why it's a free body diagram of the system of linkages. So when I was doing the calculation, what I did, sorry, let me explain. Oh, come on, can I move this picture? Come on. No, okay. Okay, so I had this system, and they wanted to know the forces on the linkages. So I had to simplify this into this picture. So this has been simplified, and then when I was looking at the forces on the pivot point, I draw this point, and then I looked at the forces acting on it, sorry, forces acting on it, and then did the calculation on this point only. And then i did I looked at this point only and applied equation of equilibrium here, and then I looked at this point here and did equation of equilibrium for this point, and that's how I found out the stresses in all the joints in this example. So what is that? It is a draw. Come on. It is a drawing that shows all external forces acting on the particle. It helps you write the equation of equilibrium used to solve the unknowns, usually forces or angles. So basically, on that particle, you will see all the forces acting on it. For example, look at this one again. If I want to know the forces acting on ring A, I will draw ring A and all the forces acting on it. That's it. This is my feeble diagram of point A. Same it says here. Okay. So, okay. So let's look at real problem how to draw feeble diagram. So it says that imagine the particle to be isolated or cut free from the surroundings. So you want to draw. I'm looking at this picture here. You want to draw the feeble diagram of point A. So I'll make a circle, cut it off from the surrounding. So I will make a point and then apply all my forces on it. So I say here, show all the forces that act on that particle. Active forces, they want to move the particle. Reactive force, they want to resist the motion. Identify each force and show all the known magnitude and direction. Show all unknown magnitude and direction as variables. So basically, it's saying that once you got your particle and you put all the forces, then you have to put all the known values like this angle given here. any magnitude given, you apply there. If there's an unknown, you don't know the force acting on this direction, you present it with a variable, and then you apply equation of equilibrium, and then you'll be able to solve the problem. It's simple as that. So remember, one thing that I want to repeat again and again, because most of the engineers make this mistake. If you want to do analysis on any one point, you cut it off from the surrounding, and then you draw a free body diagram. You do not look back to the whole system. Okay.